certain events are getting smaller actually. As n gets bigger, okay, as n gets bigger, the probability of an gets smaller actually because you are dividing by 2 power n. Okay, and you have so if it is smaller, then what you can say about this C-root probability of an equal to 0 to infinity. So it converges. Right? Okay?
Yes, sir.
So if this converges, then you have Borel-Contain lemma. The Borel-Contain lemma says that this event, which is what we call lim sup, okay, and an, is the intersection of n bigger than or equal to 1, a bigger than or equal to n, ak. I'll give you a minute. So if this converges, Borel-Contain lemma says that this lim sup has probability 0. Okay? This lim sup has probability 0. So if this lim sup has probability 0, what does it mean? That what does it mean? So probabilistically you're gonna say this supremum is going to cross this epsilon has probability 0. Okay? So if I write it precisely, I would say the quantity W of U or W of T by T exceeds
Epsilon
epsilon,
by probability.
okay, is only for finitely many values in interval
So probability maintained by the
endless. Okay? And this shows what you want.
Yes, sir.
Let me give you. Shall I give you the morning? This last part again. Okay? So the Borel-Contain lemma you get that. It's a very simple thing. It says, imagine you have a sequence of events. Okay? So you have a sequence of events A1, A2, An, whose probabilities are decreasing. Okay? Whose probabilities are decreasing. In other words, the series of probability is
Convergent.
converging. In other words, as n gets bigger and bigger and bigger, an's become more unlikely, improbable. Improbable. Are you getting the point? Improbable. So in other words, in long run, only finite of the an's will occur, not the infinite. Only few of the an's will occur, not all actually, because that's what it says that, you know, in long run, as n gets bigger and bigger, probability, so an's are getting closer, or the probabilities are getting closer to the 0. So this means that there will be only finite, you know, what do you call n's, okay? N's for which the, you know, an's will occur, you know, it doesn't have any length. Okay? So that's Borel-Contain lemma. यहाँ पर भी इसका भी मतलब यही है, ठीक है? For every n, think about it. So you take n equal to 1. For every n, you can always find an index after the n such that this occurs. Okay? Every n you can find an index k such that this occurs. Now since these probabilities are getting closer, so as this n will get bigger and bigger and bigger and bigger, okay, you will see that less and less of AKs will happen. That's what this Borel-Contain lemma says. I mean, if you still have troubles, we can discuss it tomorrow. Okay, so this is what it says essentially.